So I think when we've spoken before, we've talked about automotive, we've talked about safety, we've talked about security. One of the other really big aspects of developing chips for cars, data centers, mobile phones, smart cards is manufacturing test. And that's one area that as users of silicon chips today, we kind of take for granted that the silicon that we have in our daily devices is just going to work. But actually, it's a huge challenge to make sure that the silicon that we have today is pretty much 100% tested, zero defects, to make sure that in all those critical applications, it's going to do what it says it does without any problems. And SSN is really the next generation of design for test technology that Siemens EDA has developed over the last number of years. And it's design for test is not a new concept. People were doing design for test back in the 80s. When I say it's a once in a decade technology, what we've seen since that time is the way design for test technology has really evolved. So we've gone from using very kind of straightforward, what we call scan-based structures within the design to enable us to apply what we call ATPG patterns. These are essentially patterns defined in a series of zeros and ones, which effectively enable us to test every single transistor within a piece of silicon. Over time, the amount of test patterns and the amount of test content that we needed to be able to test a device has grown enormously. So in the early 2000s, we introduced a technology called test compress. Test compress enabled us the ability to compress that test pattern content, a small amount of logic on the chip, and some advanced algorithms when developing the actual test pattern content. We're able to massively reduce the amount of test pattern content needed to do the same level of testing. So again, that was a point in time when there was really a once in a decade new technology that really improved the overall ability to test our silicon. And then what happened is the amount of complexity in our designs and the process node that people were using reduced. So again, the amount of complexity in those designs really took us to the next once in a generation technology, which was hierarchical design for test. With hierarchical design for test, we really started to split the design up into pieces and tested it in a bit by bit type approach. It's kind of divide and conquer. This saved silicon designers a huge amount of design time and effort and tool runtime, and the ability to get their test pattern content generated as quickly as possible and as efficiently as possible. This is a great approach when designs had kind of 5 blocks, 10 blocks, even up to 100 blocks in their design. But very quickly, as you can imagine, with a technology like that, people utilize that and grow it. And we started to see designs coming through which had thousands of test blocks. That introduces a whole new challenge. How do you manage all of that test content at the top level? So SSN really then takes that to the next step. And what SSN does is it decouples the complexity at the top level of your chip design. It moves away from an ad hoc or bespoke top level integration of all your DFT blocks and introduces a common SSN bus that runs around your device. That then enables you to have as many blocks in your device as you really want and need. It decouples some of the dependencies between the top level DFT infrastructure and the block level requirements. So it's extremely scalable. The way in which we deliver the test pattern content has changed significantly. We've gone from direct pin control on the device to delivering the test pattern content in a packetized format. This really allows us to take control over the bandwidth management and how that test pattern content is delivered. So if you've got multiple blocks in your design and some blocks require more test patterns than others, we can completely balance that at the time of the test pattern generation. So this really does take test in silicon to the next level. What we're starting to see now at the silicon level, as designers try and continue to grow the complexity and the size of their devices, we're seeing the need to go towards multi-chip devices, whether that's 2D technology or 3D stack technology. So having multiple silicon die within a device. And actually, one of the beauties of SSN is it enables you to scale your test infrastructure to incorporate those multiple die. So you can now test across the die, you can route your SSN bus across multiple pieces of silicon. And the new standard, the IEEE 1838 standard, which really governs testing of multi-die chips, has the provision there for a fast parallel bus, which SSN really fits perfectly. SSN is a DFT technology that is really benefiting all of the semiconductor kind of markets, like I say, whether it's automotive, whether it's data center, mobile, because it's really enabling designers to reduce the overall test cost of their product, and in doing that, obviously reducing the overall cost of the product themselves. So, and that's like I say, enables our designers to continue to increase the size and complexity of their design, and having a DFT solution that really scales with that. In terms of what's coming next, obviously we have the whole discussion around multi-die, multi-chip modules, 3D stack devices. But looking more into the automotive space, we're looking at the ability to be able to leverage that manufacturing test content and try and bring that onto chip. So really being able to run manufacturing level test patterns and give a manufacturing kind of quality, but at an in-system type level. It's technology that's been in development for quite some time, and it's really kind of got to the point where we really looked into the future and looked at some of the upcoming challenges that we expected our customers to have. So SSN was really kind of designed to be as future-proof as possible. From my personal view, having been involved in test technology for the last 30 years, seeing the real gains that SSN brings to silicon designers and the advantages it brings to the way that we can implement test for our future products, it really is a huge leap in terms of what we can do and how we do it.